All right, let's get right into it. When you think about the incredible story of life on this planet, what's really driving the whole thing? Is it all just a series of random accidents? Or is there some kind of grand plan at work? Or maybe, just maybe, it's something else entirely, something a lot more responsive. You know, for ages, this whole debate has been presented as a simple black and white choice. It's either a complete cosmic accident or it's a meticulously designed masterpiece. And yeah, those two ideas feel like they're a million miles apart. But what if the real answer isn't on either end of that spectrum? What if it's somewhere in the middle?
So to really get where we're headed with this, we've got to first look back at the two big ideas that have really dominated the conversation about evolution for well over 100 years now.
And here it is, laid out perfectly. On one side, you've got this idea of a random walk. Picture evolution just kind of stumbling along, with no real direction or destination. Then, on the other side, you have the guided hand, this idea that evolution is being deliberately steered toward a very specific outcome. So, that random walk, that's pretty much classic Darwinism. The whole idea is that changes to our genes, mutations, are totally random. They just happen, for no particular reason. Then, the environment steps in and acts like a bouncer at a club through natural selection. If a random change happens to be useful, great. That organism is more likely to survive and pass that trait on. It's a really powerful theory, for sure, but at its heart, it's all about chance. Now, on the complete opposite end of the spectrum, you've got intelligent design. This view says, hold on, all this complexity we see in nature, there's no way that's an accident. It argues that there's a purpose behind it all, some kind of intention, guiding evolution towards a very specific and usually very complex end goal. And here's the thing, both of these ideas, as compelling as they might be, leave some pretty big questions unanswered. I mean, pure blind randomness has a tough time explaining how some adaptations happen so quickly and with such incredible precision. On the flip side, bringing a designer into the picture, well, that takes us out of what science can actually test and measure. But what if there's another way to look at this? This is where a really fascinating third idea enters the scene. It's like a middle path, one that connects the dots between randomness and purpose. So let's check out how this completely changes our view of evolution. Okay, so this new idea is called the feedback mechanism of evolution, or FME for short. And the core concept here is a game changer. It suggests that evolution isn't just a passive process of waiting to see what survives. No, it's actively responding to signals from the world around it. And the craziest part? This response happens super early, when an organism is first developing, basically getting it ready for the exact world it's about to be born into. And this, right here, is the most important thing to grasp. With this model, evolution is incredibly responsive. It's constantly adapting. But, and this is a huge but, it's not intentional. There's no plan. The environment isn't trying to do anything. It's more like it just leaves a fingerprint on the developing organism.
All right, that all sounds great in theory, but how does it actually work? I mean, how can the environment give feedback that literally shapes a species over time? Well, the process is actually surprisingly straightforward.
Okay, so it all starts with the environment sending out signals. But the really amazing part is what happens next, especially during the embryonic stage. This is where a crucial process called energy allocation kicks in. Think about it. A developing embryo has a limited budget of energy. It literally directs that energy to build up the parts that are going to be most important for survival in the specific environment it's about to face. It's like it's getting a sneak preview. And this priming during development directly influences the traits of that new generation. Now, if this happens over and over, generation after generation, that new trait can become locked in, a permanent adaptation. And if you let that run for long enough, boom, you can even get a brand new species. And we're not talking about some kind of mysterious cosmic force here. These signals are real physical things. We're talking about things like light, temperature, what an organism's mother eats, or even how much stress it's under. All of these things are sending information to the developing embryo. The theory even gets into potential quantum-level stuff, but the big ones are these very real-world inputs. It's all just data that helps shape development. So what does this all mean? Well, it completely reframes the whole picture. Instead of evolution being a series of random shots in the dark, where you're just hoping one hits the bullseye, it's more like the changes are already aimed at the target. They are often directly lined up with the pressures of the environment. Suddenly, evolution doesn't seem so random anymore. It feels way more direct, way more efficient. So with this feedback idea, we can finally step outside of that old, tired debate. It's not just pure chance, but it's not some pre-written story either. And this table just makes it crystal clear. You've got Darwinism, driven by random mutation, leading to an accidental outcome. Then there's intelligent design, a purposeful plan for a predetermined outcome. But then look at the feedback mechanism. The driving force, environmental feedback. The outcome, responsive. The key process, that developmental priming we talked about. You can see it's not just a tweak on the old ideas, it's in a category all its own.
When you start looking at things through this lens, some classic evolutionary puzzles start to look totally different. Take the giraffe's neck. Maybe it wasn't just some lucky 1 in a billion random mutation. What if instead it was the result of countless generations of feedback? The environmental signal, the fact that the best food was up high, kept priming developing giraffes to allocate just a little more energy to growing longer necks and legs. And over eons, that consistent feedback sculpted the incredible animal we see today.
And really, it all comes down to this one simple, powerful idea. This is the main takeaway. Life isn't just wandering aimlessly, but there's no director pulling the strings from behind the curtain. It's a system that learns and adapts. It's guided by feedback, not by purpose. So I want to leave you with a pretty big question to think about. If evolution is really this ongoing conversation between life and the environment, and right now we humans are changing that environment faster than ever before, what signals are we sending? What kind of feedback are we giving to the next generation of life on Earth, including ourselves?